you see the person's head is moving side to side. Okay? The cervical vertebrae, the way they are constructed, make up a set of bones, and the definition of a rotation is that the set of bones simply spins on its axis. Okay? So we have a group of bones that make a column, and they spin on their axis. That's the definition of a rotation. So I think you probably should indicate rotation for number 1. Anyone get anything different?
Rotation by itself.
You can see the person is laterally rotating, and then there is a medial rotation to bring it back. Okay? So you have muscles that are capable of doing lateral rotation, and then another set of muscles which can bring it back. Okay? All right?
On an exam, what would that be considered? A lateral rotation?
It's a rotation.
Just rotation.
Okay, it's a rotation. If you say lateral, it is in fact a lateral rotation. It is, the arrow is pointing towards lateral side. Let's look at 2 and 3. Did we get these? 2 and 3? Right. Okay. Elevate, depress. Okay. Very good. Those movements may not mean very much, but you know what? If you're really trying to exchange air, you're very likely to elevate and depress to push it all out. Okay? Number 4 and 5. Very good. Okay. This is our first example of a muscle which takes on a name of the action it does. Okay? This is prone. This is supine. No, this is supine and this is prone. Thank you very much. Don't get nasty. Okay? All right? You have a muscle right here that crosses between these two bones. It's called the pronator teres. Its action is to pronate. So that's prone, supine. I always think it's sad of a dead animal on the side of the road with its legs up. That's called supine. Okay? And if you're down like this, you're prone. Okay, all righty. 6 and 7. 6 and 7. 6 is out like this. That is a abduction with a B, and this is adduction. Now, students have told me they remember adduction because you're adding to the body. You're adding a body part to the body, so they remember adduction. Adding. Okay? 8 and 9. Very good, very good. Even though the person's arm is out here, if we look at the bone angle definition, that's a flex, that's an extension. Flex and extension. Lesson number 2. That's occurring at the wrist. Muscles here that control the wrist and cause this, almost all of them take on the first name flexor. Muscles back here, which do this at the wrist, take on the name extensor. Okay? Now there are exceptions to those rules. 10 and 11, at the hip, out like that, back down. Abduction, adduction. Abduction, adduction. Very good. Number 12, as best as a two-dimensional diagram can show it, what's supposed to be happening is this kind of movement here. That is a circumduction. I could see where you may have called it a rotation. You do get some rotational movement at the hip. Take a look. Watch my foot if you can. The ankle is locked, and I get a little bit of rotation out that way and a little rotation this way. That is occurring at the ball and socket. That's a rotation. But number 12 is trying to show a circumduction.
Which is different than rotating on its axis.
Yeah, see, right. Good, Robert. Very good. All I'm doing here is rotating these bones along the length of their axis, okay? But now I'm doing something different, okay? All right. Number 13 and 14. These are at the TMJ. Right. These are, unless you really pronounce them, these are basic chewing and speaking and facial expression type movements. Protraction to push out the mandible, retraction to bring it back. okay? 29 and 30 are also at the TMJ, and those then are going to be called excursions, where 29 will be a lateral excursion, 30 will be a medial excursion. Again, these are talking, chewing types of movements. Okay, 15 and 16 are right there. It's at the waist, and 16 is this, and 16 is that. What Robert said. Okay? You could say I'm moving the body part anterior to the coronal plane. You could say that I'm reducing the angle between the bones of my spine and the bones of my legs. Either way, flexion fits, which means that 15 is an extension. If I go way far back, then Robert would call that a hyperextension, and I'd agree with it. Okay? 17 and 18. It appears that the person is bringing the head back into normal position in number 17, so we would call it a extension, and then 18 would be the opposite. This person is doing flexions and extensions in all of these movements. Did you happen to learn that there's a special name for flexion and extension at the ankle? Very good, okay. So 19 and 20, 19, 20, we looked at these already, 19, 20. Yeah, these are movements at the ankle. Right, movements at the ankle that affect the foot, absolutely. So 19 flexion, 20 extension, 21, 22, 21, 22, flexion, extension, 23, 24, 23, 24, flexion and extension, 25, 26. Here there's a little bit of a deviation. If we go by bone angle, 25 looks like a flex, but it's not. This is called, hold on, I'm wrong. 25 does look like a flex, and it is. The hamstrings are flexors of the knee. The quads are extensors of the knee. 25 is a flexion. 26 is an extension. 27, 28. 27, what you're doing is sort of pointing the toes up. So if this is a foot and that is an ankle, in 27 you point the toes up. That is called dorsiflexion. In an old book, you'll find that the top of the foot is referred to as the dorsum. Dorsiflexion. To point the toes downward, to stand on tippy toes, is plantar flexion. Okay? All right? All right, then. That leaves us with number 31 and number 32. 31, as best as the diagram can show, is trying to show this movement here. Watch, I'm going to keep this locked. Elbow is locked. Watch the shoulder and the arm. All I am doing is rotating the humerus along its long axis. Okay? This is a rotational movement. But it's involving the humerus at the glenohumeral joint. This is a lateral. The way the arrows go, it's a lateral rotation. Okay?
What number is this?
Number 31. Number then 32, draw inversion, eversion. Imagine that this is my leg, that's my ankle, this is my foot, and that's my big toe. Okay, I'm standing. If I try to lift the foot so that the plantar surface is pointing medially, that is called a inversion. Okay? Now watch the hand again. If I try to point the plantar surface laterally, that's called an eversion. You might say, well, when the heck do I ever do any of that? Well, I tell you, if you walk around on uneven surfaces, you are constantly inverting and everting as you try to maintain your position on rough surfaces. Okay? We will learn that muscles down here on the side, the fibular side, are going to be everters of the foot. Okay? There's a muscle down there, the fibularis longus, that is an everter. Okay? Okay. Well, we don't have much time left, but I do want to make sure you get your money's worth. So let me do this. The second part of the lab today is, and I'm going to be making some changes in the schedule, so just hang loose.